Hello everyone, welcome to our Finite Elements Method second project presentation. In this presentation, we can see structures in 1D and 2D, their mesh densities with different element types, and we will see the analysis of both and we can compare them. So let's begin with beam with no voided. In this switch, we can select and change in between 1D and 2D elements. Here we can select void or inclusion for voided structures. First, let's begin with beam with no void. In 2D, we can select this beam and we can see the mesh structure of D2TR3N. We can switch in between elements. By clicking this, we can see mesh structure of 2D elements. Here we can see beam with no voided. Then let's move on to the circle voided. Let's begin with D2TR3N. Also, number of elements and number of nodes can be seen under the figure. With higher mesh densities, program will automatically work slower than the other mesh densities. For D2QU8N, now here we can see, and lastly D2QU9N. Yes. Let's move on to the square voided structure. And also for the circle voided structure, we can add inclusion, and we will see that in a minute. This is the rhombus voided structure. Here we can see in D2QU9N, in the middle of each element, one node is added. Now let's move on to the inclusion in circle voided beam. Let's begin with D2TR3N. Here we can change C and D values and see with the inclusion we have TR6N, QU4N, it takes a little bit of time because inclusion has high mesh density. QU8N, let's try it. And lastly QU9N. You can see one node will be added in the center of each element. Yeah, you can see. This pink color, as I mentioned, represents 2D elements and structures. So let's move on to the 1D elements. So we choose 1D. And let's try beam with no void, with 0 void, and also let's try these. Also user can change each value. Here is the 1Ds. So also we can add and apply extension, expansion, and shear boundary conditions. So now let's move on to the seeing, scores, analysis, and let's compare 1D to 2D. Now let's move on to the analysis and comparison with 1D to 2D. So let's begin with making 2D. In the left hand side we can see 2D, we will see, and in the right hand side we will see 1D. So let's begin with beam with no void in 2D. We are changing 2D and we will see pink, so 2D on the right. Select the extension and press run in 2D. So user can switch in between display edges on and off, and also different stress strain distributions and also displacement. Okay, now and also user can change colors. So let's be in rainbow and let's put the 1D. So we are changing 1D. Again, click the same button, so black, it is 1D, select extension and run 1D analysis. So you can see total displacement. So if we can switch in stress distribution, we can see stress distribution, and with clear buttons we can clear structures. Now let's see one more example with circle voided. So see 1D, first of all shear, and run analysis. As in the first project video, we can see results, and also switch in 2D and let's change element type to quadrilateral one. We can see pink, okay, shear, and run analysis. So actually we can see similar results and we can compare them. With clear buttons we can clear, and let's move on. For example, the rhombus and 1D. Let's see similar results. Let's try them with stress distribution, and also let's move on to 2D. Same shear, and run analysis for stress. These are stresses, strain, and also displacements. Also, let's see the inclusion. Now let's see inclusion in circle. Inclusion, let's try 3N. Circle. Also let's try shear and run analysis. So see stress XX, XY, Y center is red because Young's modulus of inclusion is much more higher than the other parts. And also user can change it. And this is for the also inclusion. Thanks for watching.